There is a unique reaction in front of you. Hydrogen, which is required for industry, is generated using water reaction with aluminium. Aluminium is pre-processed in a special way, which prevents oxide layer formation at the surface of aluminium particles. Therefore, it can effectively react with water under normal conditions. This new hydrogen production technology is an invention patented by the scientists of the Lithuanian Energy Institute, which will be sought to be used in the development of high-capacity primary batteries. The scientists of the Institute work in 5 energy-related fields: thermal physics, gas and fluid dynamics, materials, processes and technology research, nuclear energy safety and reliability, nuclear waste management, simulation and control of energy systems, and energy economics. Various researches related to hydrogen production technologies, solid-state hydrogen storage, hydrogen usage for electricity production, for the development of lightweight and high-performance batteries are carried out in the Center for Hydrogen Energy Technologies. One of the research fields is hydrogen separation from gas mixtures by using membranes. Currently, the majority of membranes on the market are composed of metals like palladium or platinum, the price of which is high. Our technology is based on membranes, the main element of which is nickel. Therefore, their price is tens of times lower. The technology is used when pure hydrogen needs to be extracted from a gas mixture by separating it from gaseous products. Polystyrene foam has also been improved in the center. This material has very good thermal insulation properties. However, the coefficient of its thermal conductivity and the rate of biological corrosion significantly increase as it gets wet. Scientists have been developing a new technology for coating polystyrene foam with a thin metal oxide coating, which allows the foam to become more resistant to humidity, fire or mold. Fundamental and applied research related to combustion processes is carried out, and combustion equipment ensuring high quality and efficient fuel combustion is developed in the laboratory of combustion processes. One of the recent examples of successful cooperation of business and science is the achieved result, ensuring limits of emission for water boiler KVGM 100 at UAB Vilnius Energia Combined Heat and Power Plant No. 2 in accordance with the requirements of the EU Directive effective 2016. After implementation of burners with the innovative design and gas recirculation system by the Lithuanian Energy Institute, nitrogen oxide emissions have decreased by 28%. Following long-lasting calculations and research, the entire recirculation line was manufactured and installed for JSC Vilnius Energia based on our drawings. The carried-out tests showed that our offered solutions were suitable for the boiler. These technological solutions were awarded the gold medal in the competition Lithuanian Product of the Year 2014. Currently, analogous technological changes are being implemented at another thermal power plant. Technologies related to the thermal treatment of biomass and waste are also developed in the laboratory. For example, the scientists who took part in an international project, Eureka, developed the prototype of gasification equipment which is operated automatically. It's capable of regulating and adjusting the gasification process to different types of fuel and can generate gas. This gas may later be supplied to internal combustion engines or turbines, thus generating electricity or thermal energy. One more innovative device, generating gases from sludge accumulated in sewage treatment plant, has been developed. Later, gas is processed by plasmochemical methods and decomposed into the simplest combustible gas. Such devices can be applied to sewage treatment plants located in Lithuanian cities. The Institute has great experience in the field of nuclear energy. It is not only research related to nuclear waste, but also new fundamental research on nuclear safety. For example, steam and water interphase interaction is being investigated in the Laboratory of Nuclear Installation Safety. This requires the usage of high-sensitivity and resolution infrared camera and the specialized LDV or laser Doppler velocimetry equipment. Temperature and velocity fields in the interacting flows are monitored simultaneously. It helps understand physical processes that take place in cooling circuits of nuclear power plants and develop passive circulation systems that employ unique characteristics of two-phase flow. In the Laboratory of Heat Equipment Research and Testing, the technologies of fuel production from biomass and their characteristics in identification of chemical composition, moisture, volatile fractions, calorific value, ash content are researched. Low-capacity compact prototypes of thermal appliances based on gasification of various granular fuels, cleaning the obtained gas in cyclonic chambers, and its final combustion in the separate chamber by supplying the swirl streams of secondary air, has been developed and tested. It allows significantly improved combustion and reduced environmental pollution by solid particles. Modern non-invasive laser measurement and visualization methods are applied for the investigation of mixing the gas flows. The research on operating efficiency and emissions of water boilers, furnaces and fireplaces, their tests and assessments of compliance with the set regulatory requirements are also performed in the laboratory. This activity is accredited and notified. Therefore, the manufacturers and market suppliers of this equipment can obtain the internationally recognized certificates which certify the compliance. Another activity field is closely related to the increase of economic development and competitiveness. The laboratory created and continues developing 4 national standards for reproduction of liquid and gas volume, flow rate and velocity units, ensuring the accuracy and international traceability of measurement and supply consumption of the main energy resources in Lithuania. The laboratory started carrying out the research on the promising technologies related to application of membranes for separation of incombustible gas components from gas mixtures and to the research on dynamics of flows in microchannels. One of the most popular of our offered services are related to biomass usage in energy production. These are the research on identification of biomass fuel characteristics, combustion processes, reduction of environmental emissions. Another research area is safety assessment and waste management at nuclear power plants. Our experience gained while working in Lithuania with the Ignalina nuclear power plant is widely used internationally through being a part of international projects, transferring knowledge to the countries having or planning to construct nuclear power plants, organization of studies and internships, providing services to nuclear power plants in Slovakia and Bulgaria. It is only a part of the laboratories operating at the National Open Access Scientific Center for Future Energy Technologies of Lithuanian Energy Institute. The institute employs more than 100 scientists and over 50 qualified engineers. Many years of experience and continuous competence development are the highest competitive advantage of the center.